Hi everyone! So my student-led activity today is on magnetism. The materials that I'm about to discuss with you can be found at Amazon, Walmart, Walgreens, CVS, Target, any kind of local convenience store, grocery store, etc. So you'll need magnets of different shapes and sizes. So I have like square magnet, small circle magnet, medium circle magnet, and then I have a large round magnet for the end of our project. And then you'll need things that will attract to a magnet, such as scissors, a washer, and then things that will not attract to a magnet, such as like a plastic hook, a water bottle, or a piece of paper. Students would also need their class set of pencils, their science notebooks, anchor chart paper, markers, your document camera and projector in your classroom, and then notebook paper for taking notes if they need so. So our procedure, students will be grouped in groups of 3 to 4 for this project depending upon your class size. Before handing out materials or starting any kind of engaging process, I let my students know that we're going to be learning about magnets and magnetism and try to pull any prior knowledge that they have previously about what they know about magnets. I do have included on my student-led activity a YouTube video that I would play first to get them engaged in magnetism, and you can see that on my handout that I have attached. Once the video is complete, I would make sure that my students are grouped into 3 or 4, and I would give each group a magnet for their table. So one table may have this size, it doesn't matter what size each table has as long as each table has one magnet. And then each table will also have a group of objects that attract magnets. Scissors, a washer, you can use keys, you can use utensils, paper clips, screws, nails, anything like that that's appropriate. And then they will also need materials that do not attract to a magnet, such as something plastic, as is a plastic clip, water bottle, crayons, glue, sponges, paper, things like that you know that don't attract to a magnet. They will need 2 sets of those materials. So once the students have their materials, what you want to let them know is that they need to take their basket. I would probably mix them together so that they're not already separated, because what their job is to then separate the materials based off of what sticks to a magnet and what does not stick. So they would randomly take one piece of material at a time to see if it sticks to their magnet. This item does not stick, so it goes into the category of things that do not stick to my magnet. They would continue on with all of their materials, making 2 separate categories. This sticks to the magnet, so this would go in the sticks to the magnet category. This sticks to the magnet, so this would go in the sticks to the magnet category. Once they have all of their supplies sorted into 2 different categories, things that will stick and things that do not stick, they need to come up with an investigation question, such as why or what. We know the what, but why do these items stick? Can magnets pass through a piece of paper? If they want to use a piece of paper and put their magnet behind it and see if their item still sticks, that's an investigation that they would then research in their group. Once they are done researching any questions through their investigation, they're going to pick the most interesting, creative one that they've come up with as a group and then present it to the class and show the class that we thought of this, putting our magnets behind a piece of paper, our item still sticks. And then they would show the class how that works. During this process, they're journaling in their science journals. Any questions, thoughts, comments. Once they present their categories and their question to the class, we are filling in our magnets anchor chart of things that we've discovered during this research and possible questions that we still may have regarding magnets so that we can discuss it as a whole group. For our final evaluation of this lesson, I put horseshoe, but if you don't have a horseshoe magnet, you can just use a a larger magnet. It's a stronger magnet from what I think. And the class then gets to decide out of all the magnets in the class, whether they're small, big, different sizes, which magnet in the class is the strongest. So each group gets to try out each magnet and see which magnet can pick up the most paper clips. They will predict first which magnet they think it is, and then at the end of our research and our inquiry, they will know then which magnet was the strongest by picking up the most paper clips. Students will assess and reflect on this research by completing their science notebook journals at their tables, so that they will compare it to their predictions on whether they were correct in thinking the bigger one was the strongest, or maybe it was the smallest one that was the strongest, and then we would share with the class. Safety precautions for this lesson. Students should conduct themselves in a responsible manner at all times in the lab or in the classroom. Students should follow all instructions carefully and ask the teacher if they do not understand something. They need to participate actively and equally in groups. Don't touch anything until instructed to do so. That's part of listening. Do not eat, drink, or chew gum in the lab. Keep your workspace clean and tidy. The teacher will always monitor students to make sure they're behaving properly. If any equipment breaks, please tell the teacher immediately. Follow all class rules throughout their lab. No calling out, and always be kind to others. The different teaching techniques that I would use with this lesson would be cooperative learning. Students will work in small groups to complete the activity. And then student discourse. Students will discuss their observations in their small groups and whole group during the activity. There are a couple of different extensions that you could use with this activity. Students can research with the help of their teacher if the temperature of a magnet affects its strength. And you'll see on my student-led activity handout, there's a website that will guide you through that process to show students whether it matters if a magnet is hot or cold and if it works better. Students could also use magnetic letters depending upon the grade level to spell their vocabulary words. Students could use them to practice addition or subtraction also. And then lastly, with the help of the teacher, students could make magnetic silly putty. It's actually a really fun process, and I've also put that website on my student-led activity, so that would be a fun, creative activity that students could do. Well, I hope you enjoyed my activity, and I'll see you guys later.